Alright, in this screencast I'd like to go through how to use your calculator to help you with your straight line graphs, and then we'll move into finding an equation of a line given some information, so working from graph to equation. So firstly, let's go in here. Now this is your TI Inspire CAS calculator, and if you hit menu you get all these options here. Now we're going to have a look at graphs, so we're going to take number 2, add graphs. And then we get this invitation to type in here an equation. So we'll do that. Sorry, I just had to pause there. My recording as my phone was ringing. Okay, so we get an invitation to type in here an equation, which we'll do now. So I'll type in say 2x minus 3, shall we say, and then hit enter, and we get the line 2x minus 3. Now let's just check this out. It's got a it's in that gradient intercept form, isn't it? So we can see the y-intercept's minus 3, 1, 2, 3. We can see that there, and the gradient's 2. We'll go up 2 and across 1. That all looks pretty good. Now, what we can do here is also we can activate a trace, which is quite useful. So I'd like to get you to practice this, and you can go to trace. Here we go. You get to trace the graph, option 1. And then you get these, and you can see it picks out the intercepts 0, minus 3, but as we arrow across, we'll pick up other points. It should pick up all the, there we go, 0, that's the other intercept. So it picks up the x-intercept at 1.5. So that's going to be a useful feature for you, and one that you want to be able to work your way around. So have a little practice of that. And we'll dart back into finding the equation of a line. Okay, so the first thing we'll do is I'll draw up a little line here. So if you get this down in your notes, something like that, and if I draw a line like so, I'm going to go through this point here, 1. I'm not going to draw it to scale actually, so I'll just bung a little line up here. So you're given the y-intercept there of 1, and you're given another point up here, which I'm just taking from the book, which is 4, 13. Okay, so we want the equations. So the challenge here, the task, is to find the equation of the line shown over here. Okay, so what we'll do is have a look at it and go, right, well, I've got the y-intercept, so let's use the gradient intercept form, y equals mx plus c. Can we see what the gradient and the y-intercept is? Because if we can, then we just need to plug in those values. So the y-intercept is 1. So straight away I can say it's y equals mx plus 1. I know that much. Now I just need to work out what m is. Can we do it just by working out the rise over run? We know it's got a positive slope, hasn't it? It's sloping upwards from left to right. That's a positive slope. So if we just work out now what our rise over run is, then we're in business, aren't we? So how far across do we go to get from this point here 1 to this point here 4, 13? So we're going from 0 on the x-axis across to 4. So that means I've gone 4 this way, and I've gone from 1 on the y-axis up to 13. So I've gone 12 that way, haven't I? So my gradient, my m, is rise over run 12 over 4, which is equal to 3, and that's positive 3. So my equation is going to read y equals 3x plus 1, just using the y-intercept format. Really easy if they give you the y-intercept. Let's have a look at an example here where the y-intercept is not given to you, and what we're going to do about that. I'll just pause for a sec. Right, if we look now at this information that we're given, here's a line. They've given us 2 points. We don't know what the y-intercept is. We should label our axes, x and y. Okay, so what are we going to do with this? Well, we could go down the y equals mx plus c route. We could go y equals mx plus c. We can make that our starting point. We would need to find out what m is. We don't know what c is in this case, so it's not quite as straightforward as the example before. But we can work out our gradient, can't we? Because we've got 2 points, and we just need to know what the rise over run is. Always the case here is just have a look at, if you've got a diagram, it's really easy. Find out these lengths here. So it's gone from, it's negative, isn't it? Sloping down. Right, this length here is gone from 7 to 11. You see that? 7 to 11, so that's 4. and this distance here is 6 minus 3 is 3. Distance is 4 over 3, but it's negative. So I would say I'm putting in y equals minus 4 over 3x. That gets me the gradient bit of it, but I don't know what my c is. Now, in order to find c, we can substitute in for y and x, or x and y, either of these two, either of the points that we've been given. So I'll show you what we mean. So I'll substitute in, sub in, should we go with 311 or 67? Quite like the look of let's go with 311. So sub in 311. So what we get from that is, that means for y we're going to sub in 11. So put in 11 for y equals minus 4/3 times x, which is 3, plus c. Now what this is going to do for us is going to solve it for c, isn't it? So look at this, 11 equals minus 4 over 3 times 3. Those 3's cancel, and we're left with minus 4. So we're left with c is equal to 15. So my equation is y equals minus 4/3 x, that's my gradient, plus 15. We worked out c by plugging in the point 311 for xy into this equation here. So that's one option. The other option is to use quite a clever little formula for the equation of the line. I'm going to deliver this to you. Formula for the equation of a line. So this is another option. So this is option 1. That there is option 1. This here is option 2. Option 2. So option 1 is y equals mx plus c. Option 2 is use the formula for the equation of a line. Now that formula reads y minus y1. I'll explain what these y1s mean in a minute. M is our gradient, x minus x1. So this is our gradient. So we still need to calculate our gradient. And x1, y1 is any other point. Any point that we know lies on the line. x1, y1 is any point on the line. Now we have to be given at least one point on the line, otherwise we can't do much with it. So using this formula, let's have a look at how this works. So y and x, they're fixed. x1 and y1, we substitute values in. We can choose 311 or 67, doesn't matter. And m's our gradient, which we need to calculate. So the first thing we're going to do is calculate our gradient. So let's do that. Let's work out what m is. Now we've already worked it out over here. We worked it out to be minus 4/3, didn't we? So the gradient is, okay, now just to throw another formula at you, our gradient is found by taking our y coordinates from 2 points and subtracting them. That represents that y2 minus y1, that represents the rise, and the x2 minus x1, the run. So if we use it on this particular, these 2 points here, 311 and 67, we can say that m is equal to, so for 311 and 67, if we just label these x1, y1, x2, y2, and we use the formula, it's y2 minus y1, so it's 7 minus 11, just subtracting one y coordinate from the other, and going in the same direction, 6 minus 3, rise over run. That's going to equal minus 7 minus 7 is minus 4, 6 minus 3 is 3, so it's minus 4/3. We found that out up here. We found it out by just drawing a little triangle in here, but you might find that this, I'm sure you will find, that this is quite a useful formula to find the gradient of a line given 2 points. Okay, and the x1, y1s and x2, y2s are just codes. So in they go. That's our gradient. So what I can write that in there, and I can use x1, y1. I can use either point, but let's stay with 311. So now my equation is, therefore, equation is y minus y1, 11, equals m minus 4 over 3. So I'm following this here. Y minus 11 equals minus 4 over 3, bracket x minus the x and the y hold. They stay. They're part of the bones of the of the equation x1 is 3x minus 3. Now, therefore, y minus 11, if we expand this out, that's minus 4 over 3x. And this minus 4/3 times minus 3, 3's cancel, so we're left with plus 4. Now, our last job is to add the 11, so minus 4/3 x, 4 plus 11 is 15. Now you can see we've got the same response there and there. Two options to find the equation of a line given that information. Okay, that's enough for this lesson. It's exercise 1F that we now need to work on. Please, we're going at a bit of a pace. Try and stay with us. I'll see you in class.